Hi everyone, and welcome to Connectionism, evolving to aid the Emergentists in taking on the Nativists. I'm Scott, and I hope we survive this together. So we'll begin by looking at the difference between the Nativists and Emergentist approaches. Then, how and why Emergentists rely on connectionist research. Then, how connectionist research actually works. Then, some implications of connectionist research on this sort of battle between Emergentists and Nativists. Then we'll look at what this means for second language acquisition, and then the limitations and the future of the connectionist approach. Hope you enjoy the trip. Linguistic patterns are not preordained by God, genes, school curriculum, or other human policy. This is coming from Ellis, who was writing with Beckner and the rest of the team. And it basically gives us a flavor of the Emergentist approach as opposed to the nativist, which we'll look at in the next slide. Basically, nativists who would buy into universal grammar and the critical period hypothesis would say that there's something about language learning that is inborn, and that in the human brain there are domain-specific mechanisms for processing language. They believe, and this is Pinker specifically, at least as far as I found in McClellan and Patterson, they believe that there is some sudden cognitive and linguistic change that's based on developmental stages, and these changes come or have to do with rule-based systems in the brain. The Emergentist approach, on the other hand, suggests that language emerges over time, that it changes gradually and it's learned gradually. And I think the car analogy is fairly fitting in this way. Cars, they came about, there was no plan, there was no idea of this is what a car needs to be all the time. But the car, the shape of it, what it can accomplish, emerged based on physical constraints, like laws, like gravity, or mathematical rules and physics and things like that, and human goals, what it needed to accomplish. And this is compared to language in that there are natural constraints. The brain has capacities in certain areas, memory and things like that. And then also human goals and interaction in society. These naturally constrain what language needs to do. And all of those changes have come about over time, and we'll get into more of that when we talk about the Emergentist sort of reliance on evolution. The Emergentists also believe that complexity always arises from simplicity. Without that sort of determinism you would expect from an organism having rules and making projections, and just sort of, again, related to the car analogy, as if there was some kind of preordained plan. Just to be clear, it's not as simple as nativist versus emergentist. The reason is because emergentists actually have two camps under the same umbrella. The first focuses on input processing. The second focuses on the processor that's processing the input. And it's the people on the sort of processor side that might argue that, in fact, nativists and emergentists aren't so different, because emergentists do rely on or account for natural brain limitations. It's just that emergentists altogether throw out the idea that there's a language-specific mechanism in the brain. Ellis writes that emergentists look to connectionism because it provides a set of computational tools for exploring the conditions under which emergent properties arise. So we find that connectionism's role is really to provide evidence for the emergentists as they challenge nativists' positions on language development and language change. Emergentists see both language and language learning as a complex adaptive system. The problem is that complex adaptive systems are super complex. One could even think of the complex adaptive system involving language as having the nature of a fractal. Anywhere along the spectrum of the use of language, global, local, individual, massive amounts of complexity arise. So perhaps if one can understand one level of language and language use, perhaps one can more or less understand them all. But let's look at this complexity a little bit. We have the brain of the individual. It's super complex. It's a network made up of neurons and nodes that can accomplish a lot, process a lot. Then we have the language of the individual, or the idiolect. It can also be represented as a network that's ever changing and developing. Words have associations, they relate to ideas in the concrete world, and in a way they can act like neurons and nodes. Then we have the group, which is made up of individuals, very complex individuals, which kind of play the role of neurons and nodes in this network. The community language, or the dialect, is, again, complex based on the language that the individuals use, which create this community language. It's ever-changing, it's a developing network, just like the individual's brain and the language in the individual's brain. So we have complexity upon complexity upon complexity. And then we have emergence. So the language is a complex network of interrelationships. As I read this, think about how crazy this is, how much complexity is involved in this cycle that arises. An idiolect is emergent from an individual's language use through social interactions with other individuals in the communal language, whereas a communal language is emergent as the result of the interaction of the idiolects. So we have idiolects emerging as dialects, and then dialects affecting idiolects, and it's just this cycle, constant cycle. So massive, massive amounts of complexity. The problem is, how can you prove the relationship between the brain and the language, between the community and the communal language? It's so complex. That's where connectionism steps in. Connectionism uses powerful tools to try to make this happen. As we start to get a sense for exactly what role connectionism plays in relation to emergentism, it's important to think of understanding language as a process of analyzing, interpreting, and utilizing streams of data. Maybe a lot like a computer. In fact, what you'll find here in this definition of connectionism is that connectionism is all about using computers to understand that relationship between the individual, the concrete, that brain, and the mind, or the processing of language, or the community, and how that community can create a dialect. We get a sense for the necessity of using computers to unravel the complexities of language when you think about the manpower and the hours it would take to try to understand the language of a single individual. First, you'd have to have a person there doing a long-term longitudinal study, tracking that person's every move, every word they said, basically every thought they've ever had. But the thing is, remember, to understand an idiolect, one needs to understand the dialect around them. So not only would you need a long-term longitudinal study of that individual, but you would need a long-term longitudinal study of every single individual in that community that would impact that individual's language. We just don't have that kind of time. We don't have that kind of processing power. That's why we recruit computers that can do all of that number crunching and processing a lot faster, and make predictions and forecasts and give us a sense, some kind of picture of what's going on in an individual and perhaps a whole community of language. So computer modeling really is the basis for connectionist research, which is the basis for emergentist argument. So let's try to understand computer modeling a little bit better. So here we have the basics of how connectionist researchers actually use computer models in doing research. They start with an assumption. They say that simple constraints lead to complex systems, which goes back to the emergentist idea that complexity always comes from simplicity, or can only come from simplicity. Then the researchers develop models that test their ideas. These models simulate learning without relying on pre-existing governing mechanisms or structures or rules. Again, the difference between innatist approaches and emergentist approaches is that emergentists don't believe that people start with any innate linguistic mechanisms. And I've actually provided a list of processes coming from Ellis, and I don't understand any of these, but they're there to read just in case you're interested. Now, the way these computer models actually work is that they're first set up to imitate the brain in parallel systems of neural structures. Then these models are often exposed to large amounts of linguistic or linguistic-like data. The models use algorithms that sort of weight various connections and processes based on whatever given limitations the researcher wants to use at that point. And these algorithms help approximate human learning. What's interesting is that these systems are purported to develop the ability to generalize and make predictions about language. For example, the competition model was fed strings of input and trained to detect basic word relationships. And based on subsequent input, this model was able to abstract the linguistic strategy for expression of agency in English. So what's pretty crazy is that it appears that these computers have learned to do quite a few things. And all of this without having language-specific mechanisms or rules programmed into them. So I have 3 examples here. In word categories, a computer was able to put the word dragon in the categories of animal, animate, and noun. Lexical semantics is a pretty interesting thing to read about. As far as this example, having no prior linguistic knowledge, a computer scored 64% on the synonym portion of the TOEFL after being exposed to 30,000 articles from an encyclopedia. And finally, with complex questions, Lewis and Ellman demonstrated that a neural network trained on examples of well-formed sentences that mimic the types and frequencies of sentences found in real language could, in fact, learn the correct form of complex interrogatives. So this is impressive in that these computers have no real decision-making capabilities. They're simply analyzing data, sorting through it, and making decisions based on the patterns that they find there. So it is fascinating that computers can learn what humans learn, and I think an interesting example of that is Deep Blue, the chess-playing computer who was able to win, the Grandmaster Championship in '97. Is that computers are not only learning what people learn, but they're also getting to the point where they can learn how people learn, in that they can kind of exhibit the same spurts and slumps in language learning that children go through as they learn their language. So we are really talking about language development here, and we'll look at some of the emergentist ideas and how connectionism has kind of bolstered their position. So the basic emergentist idea of how grammar develops in the individual is that it happens through exposure, interaction, and use. And during all of this exposure and use, patterns develop, and we're talking about co-occurrence, much like how the computer learned synonyms in the earlier example. We find that words often come together, and that's where the patterns start to develop. What's interesting is that these patterns change and develop throughout one's lifetime, which is actually an argument against universal grammar. As Beckner writes, an important point here is that the interactions that mold a speaker's grammar continue throughout her lifetime. This idea contrasts with approaches in which vertical transmission from fixed speakers is in one generation to fluid learners in the next is the dominant mechanism for change. Not only does the individual gain or develop grammar through use, but in fact the individual creates grammar through use and interaction. So it's through natural variation and repeated use that these new constructions come about. This is known as grammaticalization. And this is something that makes sense to me. I'm not sure if it makes sense to you, but if there really were innate domain-specific mechanisms at play, I imagine that grammar would stabilize at some point. And it's interesting to think of pidgins and creoles because these are really interlanguages on a large scale that have basically evolved their grammars over time. An important question to ask is, if there are no rules, what regulates the emergence of not only an individual's language, but the language of a community that's based on individuals' interactions within the community? First, we have social interaction, the types that one is capable of having with the other individuals in the community. And then domain general cognitive capacities in the human brain. So for example, how much input can one take at one time? How does one need to learn? What order does one need to learn things in? How big are the chunks that one can process? How about somebody's memory capacity? These are domain general capacities. And what's interesting is some researchers believe that there are only slight differences between the human brain and these capacities that we have for attention, rapid sequencing, for example, and lower primates that are supposedly related to us. They're only very, very slight differences, but they create huge differences in our ability to socialize and communicate. At this point, and on the closing note of that last slide, I do need to point out that it seems like evolution is really important to the ideas of emergentists and connectionists. At least it's an assumption that, that species evolve over time, and I'm talking about macroevolution. The problem in my mind, though, is that language seems to be a process of irreducible complexity. You guys might have heard arguments against evolution about the eye. Every part of the eye needed to be there in order for the eye to function. So it's inconceivable that the eye could have evolved over time. And somehow, I'm gonna read this paragraph and see if it makes sense to you. But it's confusing to me to even read it, what lends to my argument for how it's confusing that some species could have evolved language based on their brain capacities and what language needs in order to be used. So we have this idea that brain capacity limits language. Language limits social complexity. The pre-human brain would need to evolve to meet language-driven social interaction challenges. However, the brain would need to have been evolved already to facilitate such social interaction. In other words, the brain would need to evolve to use language, but language would need to exist to justify such an evolution. So I have these kind of ideas in the following paragraphs if you want to read through and kind of think through this issue yourself. Again, it seems like an issue of irreducible complexity, which makes me challenge their reliance on evolutionary ideas. So it does seem clear to me, however, that language does evolve over time. And I see no reason to challenge this idea as long as it only concerns language and culture, or ideas, and not physical changes that cross species-specific lines. It's time to move on to the battleground. Real issues that nativists take strong positions on that emergentists are challenging, with connectionist research underneath them or behind them. So I've listed 4 of those issues here. The first is the critical period hypothesis, which is essentially the idea that at some point, at a certain age, there's a significant change in an individual's ability to process language, or in kind of how they process language. However, McClelland and colleagues demonstrated that critical period effects for phoneme perception could be achieved in a neural network, even when the mechanisms underlying learning remained unchanged. Then there's the poverty of stimulus argument, which is basically that children can produce language they've never heard and at a higher quality than what we assume they've heard. However, Ellman points to connectionist research that has dealt with elements of this position, including how learning word segmentation categories and syntax could take place given input generally available to children. Then there's the idea of the loss of plasticity over time. We know that it seems that it's harder for older people to learn language because of the argument of brain plasticity, which hopefully doesn't have much effect, thanks to at least Luder's research. Hopefully we learned something about that. Anyway, Marchman demonstrated that entrenchment and a loss of plasticity occurred even when the learning mechanisms in a model were unchanged. And that's an interesting thing to read about. You should check it out. Then, of course, the U-shaped curve as related to rule learning. Rumelhart and McClellan were able to show through simulation that U-shaped behaviors might arise in the course of item-based learning, even though those mechanisms for, or algorithms or whatever they were, even though those mechanisms didn't change, there was still a U-shaped curve. As you all know, the 4 issues found on the last slide are all pertinent to second language acquisition, but let's spend a few minutes to talk specifically about implication of connectionist research and emergentist thinking to second language acquisition. You might have gathered, based on what we've talked about so far during this presentation, that emergentist and connectionist ideas about second language acquisition are actually similar to their ideas about first language acquisition. And this is because the processes that were available, which were simple and based on domain general brain capacities and functions, are available throughout the lifetime. So basically, language learning for the child in their first language, and then for the adult or for anyone learning their second language, is still based on input and use. And of course co-occurrence and all the other factors that come in to learning language. What's interesting is that as the interlanguage emerges, the emergentists and connectionists would still say that there's no such thing in this process as top-down governance. There are no innate mechanisms that rule even interlanguage, but instead they emerge from the dynamics of language use. Emergentists and connectionists do, however, have to account for the fact that learning one's second language is somehow different from learning one's first language. And we've talked a lot about those kinds of issues that come up in language acquisition here in this class. One way that emergentists and connectionists have dealt with this issue is to demonstrate with computer models that entrenched patterns are difficult to unlearn. So basically, habits that develop over time, gradually, are difficult to override. Which seems clear, but it's great to use computer models to demonstrate that. A second factor they point to is the fact that learning environments for one's L1 and one's L2 are very, very different, especially if it's an adult learning the L2. Basically, as an adult, you're dealing with a different world. You're dealing with adult problems. You're hearing adult language. You're interacting with adults, and there's a lot more culture involved, a lot more affect involved, all those kinds of things. So they do point to the fact that to learn your L1, you're in a certain kind of environment that's very different from the environment you'll have when you learn in L2. There are a couple of predictions that come from this emergentist or connectionist point of view that are perhaps commonsensical. The first one is that adult language learners in a naturalistic setting will achieve basic variety English, which is basically a simplified version of English. Second, adult language learners who focus on form will progress further than those who do not. Seems pretty obvious, but again, this comes from the idea that habit really matters, but that these people could, given the appropriate amount of attention and instruction, they could achieve a whole lot more. It's just that they probably, in, again, a naturalistic setting, won't, which is something we observe all the time. And this is actually really interesting. It kind of goes back to the very beginning when I was talking about fractals and how complexity at every level of language matters. So change at every level of language matters, not just the individual, but also the community level. So there's a prediction about the English language, and I'll read that first quote. Languages are streamlined when history leads them to be learned more as second languages than as first, which abbreviates some of the more difficult parts of their grammars. So basically, the prediction coming from the Emergentists and the Connectionists is that English will become simplified over time. And so here are some facts. English is no longer a language spoken primarily as an L1. The 375 million L1 speakers are in a very definite minority compared to the 750 million English as a foreign language and 375 million ESL speakers. This preponderance of adult language learning of English is changing the nature of the language. Seidelhofer described these changes as English is used across the world as a lingua franca. First and foremost on her list of observables is dropping the third person present tense S, as in, she looked very sad. So you can see over time, English is going to change, and it's because we're teaching people English. Pretty interesting, I think. So to conclude, I want to talk about a few limitations that are actually cited by people in the field themselves of the Emergentist and Connectionist approaches, and then where people in the field plan to go from here. So a large set of limitations comes from the fact that we're still talking about computers versus humans. And the analogy is great. I mean, the analogy that computers can learn like humans, or the human mind seems to be like a computer. The fact is, though, it's still an analogy, something that connectionist researchers are really trying to deal with. They're trying to make it a really strong analogy, and in fact, they're trying to connect the mind and the self to the processors in the human brain. They're trying to do that. But at this point, in my understanding, it's still an analogy. One thing is still like the other. Another point is that the human mind has come up with a massive complexity as far as grammar. And to my knowledge, and I guess the knowledge of at least one of the authors I read back in '98, is that they've only scratched the surface. I'm sure they're doing a lot of great things, learning about phonemes and inflections and stuff like that. But computers still have to learn to deal with negation and subject drop and relative clauses and cleft sentences and all kinds of other stuff that they haven't been able to account for yet. More problematic still is the fact that humans have eyes and ears, and they're able to process all kinds of input a lot faster and with a lot more accuracy and complexity than computers. Computers don't have eyes and they don't have ears, so they don't even have that kind of input to help in, say, focusing attention or listening. So there's a level of complexity that computers aren't even near touching. Then there's the problem of the human self, the fact that there's an identity, there's the mind, there's moral judgment, things that computers don't seem to have access to. And then a major problem is the fact that children actually do have choices. They have their own agendas, they have drives, they have desires, and these are things that computers could attempt to have, but they really don't. I mean, they're literally limited to math and processing probabilities and variables. They're not children with their own minds and their own feelings and decisions ahead of them. And the final and probably most problematic limitation is the poverty of stimulus. Though I referred to it a few slides ago on the issues slide, it still seems to be the biggest problem for the connectionist and emergentist approaches, at least according to people in that field. For as Carroll and Mizell point out, the connectionist accounts fail to explicate that human beings possess knowledge that goes beyond the input, a point that is the very heart of the logical problem. But despite all of these limitations, the fact is that computers are helpful. One way computers can help is to augment data that comes from actual research out in the field. Another way that models can help is they can point researchers toward important insights about the mind and about language learning. And finally, the models that connectionist researchers create could be the bridge between disciplines, say between psychology and biology. As they really do try to stand for the mind, they really do try to do or to accomplish with computer models what the human mind does, if in the end they are able to create models and computers sophisticated enough to actually perform tasks the mind performs, then we essentially do have a bridge. We have the physical, yet we have the abstract of the mind, and we might have an understanding of how that all works based on computer models, which is a pretty incredible idea. Something to look forward to over the next, I don't know, centuries, I guess. So thanks everyone for listening patiently and being willing to think through all of these issues. I don't know who's going to win this battle over the human mind, whether it's the nativists or the emergentists. To be honest, I prefer the emergentist approach. I like to believe that people are capable of learning throughout their lifetimes. I prefer the analogy of language existing in the mind, in networks and associations, really similar to the way that the brain is set up. I really value a lot of the ideas that come out of the Emergentist approach, and it's great they're able to use computers and models to simulate, the processes that you and I experience every day to help us learn more about what actually happens. And I know they have a lot of work to do as far as, computer programming and all of that, and I know I have no chance in helping with that kind of stuff. But this is a field to watch very closely, and I think the developments that we could learn here could have a massive impact on our understanding of not only language but psychology and the fundamentals of the human mind. So again, thanks everyone for listening. I hope you finish strong in this semester. Blessings. The next 6 slides are something of an appendix. I've included some definitions I found in McClellan et al. And you can just flip through those, read a few of them if you're interested. If not, see you later.